All right, the Subcommittee on Research and Technology will come to order. Good afternoon, everyone. Welcome to today's hearing entitled Scientific Research at the Smithsonian. In front of you are packets containing the written testimony, biographies, and truth in testimony disclosures for today's witnesses. I now recognize myself for 5 minutes for an opening statement. Founded in 1846, the Smithsonian is the world's largest museum and research complex consisting of 19 museums and galleries, the National Zoological Park, and 9 research facilities. In addition, the Smithsonian Institution houses 137 million objects, and probably increasing every day, artworks, and specimens. The institution has been busy digitalizing its records with 8.45 million records currently available online. In 2013, 31 million people visited Smithsonian museums, and there were over 102 million visits to its website. However, the Smithsonian Institution is more than a museum. It's home to 9 research centers and numerous research programs, which range from astronomy to marine biodiversity and ecosystems of Florida to understanding tropical biodiversity. Today's hearing will focus on the world-class scientific research activities at the Smithsonian Institution. In 2013, the Smithsonian's sub-millimeter array peered through the galaxy to provide the first clear view of W49A, a stellar nursery where star formation takes place, revealing a giant star cluster in the making. In another finding, a team of Smithsonian scientists further explored overlooked preserved museum specimens. The journey that started at a museum in Chicago led to the cloud forests of Ecuador in the northern Andes and back to the genetics lab in Washington, D.C., ending in the discovery of the Olinguito, the first carnivorous mammal species discovered in the Americas in 35 years. This discovery was one of the top science stories of 2013. In other research, the first wild horse species was born from artificial insemination at the Smithsonian Conservation Biology Institute. These are a few of the highlights among the research being done that we will hear about during today's hearing. In its 168-year history, the Smithsonian has inspired millions of Americans and also given us the opportunity to learn about our nation's history, culture, and values. At the same time, it is important that the Smithsonian focus its resources on research that will maintain its world-class status and will allow its researchers to solve problems that are vital to the national interest. Our witnesses today will display and have displayed some of the important research activities that are ongoing at the Smithsonian and will provide a vision for future activities. I look forward to hearing from our distinguished witnesses and having a productive discussion. With that, I'll now recognize the ranking member, Mr. Lipinski from Illinois, for his opening statement.
Thank you, Mr. Chairman. I want to thank the distinguished witnesses who are testifying here today. Many of us remember school field trips and family outings to local museums, zoos, and aquaria. And you only have to visit the National Mall on any given weekend to see droves of young kids and families in line to see a range of Smithsonian exhibits. From the full skeleton of a stegosaurus at the Museum of Natural History, to the command module of the Apollo 11 moon landing at the Air and Space Museum, and a little further northwest, Bao Bao, the giant panda cub at the National Zoo, who has gotten so much attention. I have to say, for not the Smithsonian so much, but back home, certainly was important to me, and as a kid going to the museums there and the zoos there. So for young people, the Smithsonian, thousands of museums and other science centers around the country provide some of the earliest exposures they have to science and some of the things that really hook many of them into an interest in science. We heard a few years ago from the Chicago Zoological Society's Brookfield Zoo about their informal education programs and the important role they play in my own community. I'm co-chair of the Congressional Zoo and Aquarium Caucus and have long been an advocate of the important role of museums, science centers, zoos, and aquaria in informal science ed. This committee held a hearing last June to hear more about the administration's proposal for the Smithsonian to take on new leadership in federal efforts on informal STEM education. While the Smithsonian has an impressive track record in providing informal education, it doesn't do everything that other science agencies now do. For example, unlike NSF, the Smithsonian does not make grants to external organizations, including science centers and museums across the country. I'm interested in hearing how the Smithsonian, in its proposed new role, would strengthen the partnerships it has with its 184 affiliate museums, and how these local organizations and communities they serve will continue to benefit from their long-standing partnership with the federal government. In addition to the opportunities it provides as a collection of museums and centers of science education, the Smithsonian is also a leading research institution, as Chairman Bouchon mentioned. The scientists at the Smithsonian's research centers conduct research on many topics of today's most interesting and important science, from species preservation to climate change. Smithsonian collections also allow great science to take place and allow its millions of visitors a first-hand glimpse of our natural history. However, if these collections are not preserved, all this work could be lost. This committee included a provision in the 2010 America Competes reauthorization requiring OSTP to develop consistent policies for the management and disposal of federal scientific collections and ensure development of an online clearinghouse for information on federal scientific collections. The Smithsonian is a natural leader among federal agencies in this effort, along with the U.S. Department of Agriculture, which has significant collections of its own. I'm interested in hearing from the panel what means are being taken to preserve these artifacts and digitize them so that they can be studied and viewed for generations to come. And finally, the way the Smithsonian is funded is somewhat unique since it receives around $800 million annually in federal appropriations in addition to its many sources of private funds. But as everyone knows, we've been in a reduced budget environment which the Smithsonian has not escaped. The American people also have slimmer checkbooks and as such may not be donating in the amounts that they have in the past. I'd be very interested in hearing how the Smithsonian is prioritizing their research and what challenges they have faced during the last few years of budget cutting. Again, I want to thank Chairman Bouchon for calling this hearing and witnesses as well for being here. I look forward to your testimony and a productive discussion. With that, I'll yield back.
Thank you very much. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Our first witness today is Dr. G. Wayne Clough, and he currently is the 12th Secretary of the Smithsonian Institution. Since he began as Secretary in July 2008, Dr. Clough has overseen several major openings at the Smithsonian, including the reopening of the National Museum of American History, the David H. Koch Hall of Human Origins, and Sant Ocean Hall at the National Museum of Natural History. Before his appointment to the Smithsonian, Dr. Clough was president of the Georgia Institute of Technology for 14 years. He received his bachelor's and master's degree in civil engineering from Georgia Tech and a doctorate in civil engineering from the University of California at Berkeley. Dr. Clough will be retiring later this year as the Secretary of the Smithsonian. I'd like to take this opportunity to thank you for your hard work these past 6 years and wish you well in future endeavors. Our second witness today is Dr. Eva Pell. As Undersecretary for Science at the Smithsonian Institution, Dr. Pell directly oversees the operations of several museums, including the National Museum of Natural History, the National Air and Space Museum, the National Zoo, and its Conservation and Research Center in Front Royal, Virginia, and the Smithsonian Astrophysical Observatory in Cambridge, Massachusetts. You have time for all that? Dr. Pell was a professor in the Department of Plant Pathology at Penn State University for more than 35 years. In her role as Senior Vice President for Research at the university, Dr. Pell spearheaded the development of cross-disciplinary institutes for life sciences, materials, energy and environment, social sciences, cyber science, and the arts and humanities. Dr. Pell earned her B.S. in biology from City College of the City of New York and a Ph.D. in plant biology from Rutgers. Thank you. Our third witness today is Dr. Kirk Johnson, who is currently the Sant Director of the National Museum of Natural History and was appointed to this position in October of 2012. In his previous position as Chief Curator at the Denver Museum of Nature and Science, Dr. Johnson oversaw a 70-person research and collections division. From 2001 to 2006, Dr. Johnson was the chair of the museum's Department of Earth Sciences. Between 1991 and 1995, he was one of the two scientists who led the development of Prehistoric Journey, the museum's permanent exhibition about the history of life on Earth. From 1989 to 1990, he was a postdoctoral research associate in the Department of Botany at the University of Adelaide in Australia. He was a marine geologist with the U.S. Geological Survey in California from 1982 to 1983 and has been a research associate at the Burke Museum of Natural History and Culture in Seattle since 1991. Thanks again to all our witnesses for being here this afternoon. As our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of the committee will have 5 minutes each to ask questions. I now recognize Secretary Clough for 5 minutes to present his testimony. Welcome, sir.
Thank you, Mr. Chairman, and thanks for this opportunity to testify. I was last here in 2010, and at that time we were in the early stages of implementing our new strategic plan. Since then, we've made considerable progress towards all of our goals, much of this relating to our science museums and our research centers. Many of you just saw compelling evidence of that progress if you were able to visit with our staff members here. I'm extremely proud of our 500 scientists at the Smithsonian and what they do to help us understand our world, our universe, enable us to create a sustainable future for future generations. The scientists you just met demonstrate the passion all of our employees at the Smithsonian have. And that's why, for the past 4 years, we've been named as one of the best places to work in the federal government. The Smithsonian, as was mentioned, is a public-private partnership. Roughly 60% of our funding comes from federal appropriations and 40% from other sources. We've worked hard over the past 5 years to enhance our private funding and use it in a way that best complements the federal funding that we receive. With our strategic plan as a guide, we've attracted increased support from donors and funding agencies to make progress we would not have imagined a decade ago. Last year, 31 visits were made to our museum, the best attendance we've had in a decade. For the millions who could not visit, we're doing more than ever to reach them through our traveling exhibition service, our 184 affiliate museums, and digital technology. More than 140 million unique visitors used our websites last year. We're now delivering educational materials geared to state standards to all 50 states. This is a passion of mine because I'm an educator by life. I was raised in a family of modest means in a small rural town of Douglas, Georgia. I didn't experience the Smithsonian until I went to college. Our strategic plan documents our commitment to ensure people in any part of our nation can access our resources, and we're working hard to deliver on that promise. As noted, we were founded in 1846, and the Smithsonian is the world's largest museum and research complex with 19 museums and galleries, the National Zoo, 9 research centers, 20 libraries, and archives. As noted, we have 137 million objects in our collections, and 127 million of these are scientific objects, many of which you've seen here. We're active in more than 130 countries through our research and education efforts. Last year, we had more than 3.8 million social media followers on Facebook and Twitter. The Smithsonian Channel now reaches 30 million people and families and households, up from 6 million 5 years ago. Our strategic plan, under our strategic plan, our activities are organized to focus on 4 grand challenges, 2 of which are focused on science. The first is understanding and sustaining a biodiverse planet. The second is unlocking the mysteries of our universe. The plan also calls for greater emphasis on cross-disciplinary research and collaboration and cooperation with other science-based federal agencies, universities, nonprofits, and industry. 2, increased science-based educational offerings. And 3, improved attention to care of collections. Our collaborative and cross-disciplinary approach is exemplified by something we call the Forest Global Earth Observatory, a network of more than 50 sites around the world where long-term, standardized observations of forest changes are made. The data are organized and stored digitally so all scientists around the world and teachers and students can use the information. More than 20 countries, 9 U.S. universities, and the U.S. Forest Service participates with us in this effort. And thanks to a generous donor, We've recently launched the Tenenbaum Marine Observatory Network, which will perform a similar monitoring task to the forest effort in our coastal waters. As the partnership expands, many other universities and science agencies will join our initiative. Our scientific research forms the basis for educational resources offered in digital online lesson plans. We also offer direct assistance to school districts through the Smithsonian Science Education Center. For 28 years, the Center's innovative STEM program has been improving the K-12 science education in our nation, and in 2011, it won a highly competitive I3 Innovation Grant from the U.S. Department of Education to work with school districts in New Mexico, Texas, and North Carolina, serving approximately 90,000 students, most of whom fall in the Title I classification. Assessments of this work have shown it to be extremely successful, and more will come from this work since we're expanding it to workforce education. As I look back over the past 5 years, I am proud that our scientific efforts have made a difference, and we're positioned to do even more. As an educator, I'm also proud of the fact we've increased participation of interns and fellows. Last year, we had more than 1,300 interns and 700 fellows working at the Smithsonian. And though we don't offer degrees, we help educate the scientific workforce of the future. Of course, we also continue to what we do best, and that is inspire young people to learn more about science and our world. You may have heard of high school junior Jack Andraka from Maryland, who devised an inexpensive and quick test for pancreatic cancer after his uncle died of that disease. For that, in 2012, we presented him with our American Ingenuity Award for Youth Achievement. As a young boy, he was inspired by coming to the National History Museum. That's the power of science, to change the world with ideas and make it a better place, and that's what we do best at Smithsonian.
Thank you very much. I've subscribed to Smithsonian Magazine, by the way, for many, many years. I'd recommend it to everyone. It's a great magazine.
Thank you.
Now I recognize Undersecretary Pell for 5 minutes for her testimony.
Thank you for the opportunity to testify. To most people, the Smithsonian conjures a public place on the National Mall. We are a remarkable tourist destination, but behind that is a world-class research infrastructure making a difference in the lives of Americans. The Smithsonian conducts scientific research through a blend of remarkable collections, field sites, and observatories on Earth and in space. These assets allow our scientists and collaborators to address significant questions, from understanding the origin of the universe to explaining losses in biological diversity around the globe. To demonstrate the rich depth and breadth of Smithsonian science through collections research, exploration, and educational outreach, I would like to take you on a journey of flight. We're cleared for takeoff from the hill, so let's take a short hop down the mall. We land at our National Air and Space Museum, where our future pilots, engineers, and astronauts look at the museum's impressive collections encompassing 60,000 objects, ranging in size from rockets to space helmets to microchips. These youngsters attend lectures, family events, and educational programs that often feature pioneers in aviation and space, including pilots, astronauts, and scientists. Each day, explainers bring the science of flight alive in the How Things Fly gallery. We continue our journey now and explore the real dangers of airplanes face. You met our scientist, Dr. Carla Dove, who is instrumental in keeping you and millions of pilots and passengers safe in flight on both commercial and military flights. Dr. Dove is an ornithologist and a forensic expert who identifies the birds that can cause airplane crashes like that of the commercial flight in the Hudson River, January 2009. Carla runs the Smithsonian's Feather Identification Lab at the National Museum of Natural History. The aviation industry relies on Carla and her lab to identify the birds involved in thousands of collisions with planes every year. The Smithsonian has interagency agreements with the Federal Aviation Administration, the U.S. Air Force, and the Navy. Carla's identifications help scientists and engineers take action to avoid a crash through activities like altering an airplane's flight path or implementing bird habitat management schemes at airports. Carla receives more than 8,000 samples per year, called SNARG, to identify birds via feather identification or DNA analysis. We can help because of our unique, comprehensive collection and the specialized training of our staff. Thanks to Carla, we're safe to continue our metaphorical flight. Now we're going to go and visit subcontinents, Asia, Africa, and South America. The question is, when we go home, how do we know we're going to be alone? What if a virus, a rodent, or an insect is hitchhiking a ride on our plane? We or others we come into contact with may end up getting sick when we get home. The diseases can be caused by pathogens that are carried by animals and insects, causing zoonotic diseases that are spread between animals and humans. You've heard of SARS, malaria, and West Nile virus infection. In fact, about 75% of recently emerging infectious diseases affecting humans originally infected animals. Because of extensive international air travel, these diseases can travel undetected very quickly, posing serious public health and economic threats. To respond to these diseases, the Smithsonian is a partner with USAID on the PREDICT project, charged with predicting and preventing such problems. Our scientists help build pathology skills so that scientists in the developing world can help identify the cause of animal deaths, both wildlife and agricultural, often an important indicator of disease threats that could jump to humans. In November of last year, scientists in the Middle East found a disease called Middle East Respiratory Syndrome in camels in Qatar. The SARS-like coronavirus, which emerged last year, has killed 40% of the 170 people to whom this virus was transmitted from camels. Pinpointing camels as the disease required a range of tests, including DNA sampling and antibody testing. The Smithsonian was able to help by providing a baseline comparison for these samples through use of our collections, which include 30 years of banked serum for more than 100 species that we have at the National Zoo. The Qatari Health Council, armed with this information, was able to issue warnings for vulnerable populations to avoid close animal contact. Our scientists and colleagues helped nip this problem in the bud before it walked onto a plane. Our brief journey has come to an end. We can land safely now, but the possibilities for future exploration for you and your constituents are endless at the Smithsonian. Please come visit our collections, our field sites, and our observatories. Meet more of our dedicated scientists, and I promise you an incredible journey you will not forget. Thank you.
Thank you very much. I was interested in the word snarge. It's one of those words that kind of sounds like what it is. I now recognize Dr. Johnson for 5 minutes to present his testimony.
Thank you, Mr. Chairman. I'm going to talk today about the research, the collections, and the public impact of just one of the Smithsonian museums, the National Museum of Natural History. This is the largest of the museums. Not only is it the largest Smithsonian museum, but it's also the largest natural history museum in the world by far. And at natural history museums, we really do only three things. We do basic scientific research, we guard and use the nation's science collections, and we inspire and educate our public who knows they learn best when they're having social fun time with their families. We have more than 7 million visitors each year at the National Museum of Natural History, which is an amazing number. It's the most visited museum in the world. And 84% of our visitors come from out of town, which means they're unique visitors, which means every year we get a different 84% of 7 million, which means in a decade we might see as many as 60 million people in that one building on the National Mall. That makes this the premier science education space in the world. And it means that something like 20% of the American population will walk into that building every decade. So it's a phenomenal asset for communicating about the natural world. We also have more than 90% of the Smithsonian's collections, with 127 million objects, specimens, and artifacts. And this is where we keep the objects that we treasure about the world and study those objects. We have 11,000 scientists who visit us each year to study those objects here in our facility in Suitland, Maryland. We are the home to the iconic Hope Diamond, and we are the real Jurassic Park. With more than 200 scientists, we have the largest museum science staff in the world, and these are scientists who have three primary areas of expertise: the study of Earth and similar planets, the study of the diversity of life on Earth, and the study of human diversity and cultural change. They publish more than 600 scientific books and papers every year, often describing new species and making discoveries about plants, animals, and organisms around the world. Also embedded in the Natural History Museum, we have scientists from the U.S. Department of Agriculture, from the U.S. Geological Survey, from the Department of Defense, and from NOAA's National Marine Fisheries Service. They're there because our collections allow them to do the work they need to do. Things like preventing our troops from getting malaria, things like preventing invasive pests from crossing our borders, and understanding the vulnerabilities of our fisheries stocks. Today we had a number of scientists here. I'll just mention one of them. Dr. Tim McCoy is the chair of our mineral science department, studies meteorites. And if you ask him why he studies meteorites, he'll say, well, I want to understand the formation of the solar system, which seems a little bit ethereal to a lot of us. It's a very important topic, but you have to think back in February, just a year ago, in Russia, when the Chelyabinsk meteorite exploded over Russia, there was a meteorite the size of a bus traveling at 5 miles a second that, depending on how it came in, could cause tremendous amount of damage. We know that a 6 mile diameter asteroid is probably what caused the extinction of dinosaurs and most life on Earth 66 million years ago. So these things are real and they're in our time frame and we need to understand them, and that happens at a place where we have the world's collections of meteorites. You saw the work of Dr. Chris Helgen, who is a mammologist who, at a very young age, has discovered dozens of new species of previously undescribed mammals by looking at collections and visiting natural habitats around the world. These experts represent a dedicated staff, but they're also the inspiration for what we present to the public as our various exhibits. And this last year, we partnered with the National Human Genome Research Institute at the National Institutes of Health to put together an exhibit called Genome, Unlocking Life's Code. This is in celebration of the 60th anniversary of Watson and Crick's discovery of the double helix structure of DNA, and the 10th anniversary of the discovery of the decoding of the human genome. And this is one of these very rapidly evolving fields in science and medicine where we're all really interested in what's going to happen, and a really good place to get started learning about it is to come down and see the exhibit on the mall. In December, we opened a 10,000 square foot exhibit called Curious, and this is a place where we've turned the museum inside out and made our collections, our scientists, and our scientific equipment available to primarily teenagers, as we know that people will study things if they're very interested in them, and we find that museums are a great way to catalyze people's curiosity. We will be opening in a few years a complete renovation of the nation's fossil halls, which originally opened in 1911 as the Hall of Extinct Monsters. And in the last century, we've learned so much about the history of the Earth and the story of dinosaurs that we are going to be renovating that entire space. And later this spring, we'll be bringing to Washington, D.C. a complete real Tyrannosaurus Rex in partnership with the U.S. Army Corps of Engineers and the Museum of the Rockies. It'll be the first real Tyrannosaurus Rex in the nation's T-Rex in Washington, D.C. And we will use that to launch our renovation of the major dinosaur halls, which will open in 2019. So as you can see, the Natural History Museum is a curiously successful blend of three very different things: very serious science, our treasured objects, and a deeply engaged public that is learning while it's having fun. Thank you very much.
Thank you for your testimony. I've also watched movies about you guys, like that Night at the Museum. Yeah. I would like to remind the members that the committee rules limit questioning to 5 minutes. At this point, I'll recognize myself for 5 minutes for questioning. Really to all witnesses, with regard to scientific research, what does the Smithsonian Institution bring to the table that cannot be achieved by other federal agencies like the National Science Foundation or NASA? Can you just describe things that might be unique to the Smithsonian?
I'll get started. The agencies obviously have different missions, and I served on the National Science Board and was a researcher with NSF funding for many years. We don't fund other groups. We do work with other groups. And our collections, in one way, we would be different from the others. We have the largest, as Kirk described, scientific collection in the world. And it works a little bit like a national lab, the way I see it, because it serves as a tremendous resource base for all the other scientists to come in and use the collection. We are the caretakers in a way in that way, but we use it for our own research as well. And the interesting thing is collections have become far more important to us in our research endeavors because of genomics and some of the new scientific instruments and tools that we have. So there's sort of a new day, if you will, for our collection. So collections is one of those things. A second way is, I mentioned the Forest Global Earth Observatory and the new marine observatories, which Dr. Pell really has made happen. Those are long-term projects. The Smithsonian is very good at collaborating, bringing together teams, and then carrying out work that you can sustain for long periods of time. We're trusted around the world. I mentioned Forest Geo has over 20 countries involved in it. These are countries that want to share information with us. They trust us as a source of reliable information, and they trust us with the data. So I think that the ability to do long-term research, the collections, and the capabilities really of our scientists, unique capabilities of our scientists, are some of those things. My colleagues might want to comment otherwise.
Dr. Pell?
Well, I would just build on what Wayne talked about, because coming from a university where I worked most of my career, and you're very much confined as a faculty researcher by the term of your grant, having the federal appropriation that allows us to establish programs and know we'll be there in 5 years and 10 years and 50 years is a huge, and 100 years is a huge difference. And as a result, many faculty send their graduate students here, and postdocs come here for that experience to work with in an environment that has that kind of a longevity.
And I'll just agree with what both have said, but just to add the fact that we do very basic research on what is on the planet, the life, the rocks, the minerals, and that's a very baseline sort of research that underpins so much more of the innovative and applied researches that are out there.
Dr. Pell, a question about so-called big data. Obviously, we're talking about digitalizing everything, and we talk about that a lot. Specifically, how's the Smithsonian handling the issues of data access, data management, storage, curation, cost control? Because obviously, and Dr. Clough can answer this too, obviously that's really advancing quickly. And how's the Smithsonian trying to address that?
That's a huge question, and I want Kirk to weigh in as well, because we have 137 million objects, and we have a mandate to make what we have available to the world, and the best way to do that is through digitization. And so we are on a march to digitize our collections, and we are also very much interested in open access at every opportunity that we have. This past year, we had 3 presidential fellows who came for the very purpose of trying to help us figure out how to do our digitization more rapidly than we'd been doing it, and we've been taking advantage of crowdsourcing. And an example I find very intriguing is, as a plant biologist myself, biologists go out in the field and they have field notebooks, and they write all this information down. And what you really want to be able to do ultimately is to access those digitally, but you also would love to be able to search them digitally, which is different than just for making PDFs, imaging things. And we've started this transcription program for field notebooks and put it out on the web and said, anybody interested in, you can bring it up online, but it needs to get, it's handwritten and it needs to get digitized. And it's remarkable. Am I remembering 1,100 people? Is that the right number? Of people from all over have been inputting these data, and we've been verifying it, and we see ourselves doing more and more of that. And
I would make one other quick comment. We do deal with the big data, and we have big data challenge. The Smithsonian Astrophysical Observatory is awash in data because they are actively observing the heavens from multiple points of view and retrieving enormous amounts of data. Then these we think are images, but it's actually digital information. The genomics initiatives we have underway are going to generate an additional wave of data. So with Dr. Pell's help, we've been having discussions with Oak Ridge National Lab, Department of Energy. They're very interested in what we're doing, and obviously they have greater capacity in terms of handling big data than we do, and we look to partner with them in the future. They did say after they left, they told me they thought we had very interesting problems, and I thought that was a compliment.
It is. I now recognize the ranking member, Mr. Lipinski, for 5 minutes.
Thank you. I want to go back to the something I talked about in my opening statement is STEM education and informal science education. Like I said, I know a lot of my interest in science came in part from visits to great museums in Chicago, like Museum of Science and Industry, going to Brookfield Zoo. In fact, research has shown that as much as 80% of science learning occurs in informal environments like these. So I want to ask Dr. Johnson, if putting on your hat as a former chief curator and vice president of the Denver Museum of Nature and Science, can you talk about the challenges faced by museums and science centers across the nation in terms of availability of funding for developing and maintaining exhibits and educational opportunities for youth youth in the public, in the communities that they serve. And also how talk about that, but also how the Smithsonian can be helpful in that regard.
Sure, it's a very interesting topic. We do know that something like 95 million people a year go to science and technology centers, and it is a very pleasant way to learn very important things. There's been a trend in the last several decades for there to be fewer and fewer scientists at science centers. And as a result, the content isn't necessarily always there. So one of the things the Smithsonian can and is doing is helping to supply science-based content to the museums around the country, because it turns out that it's difficult at a certain scale to maintain collections and scientists and still run a viable standalone science center. And what we've seen in many cities across the nation in the last few decades is the decrease of the health of science and collections at natural history museums, and the growth of science centers, which don't have to bear the costs of maintaining collections and scientific researchers. So this is where being the mothership of the museums allows us to share our resources quite well. We have a product called the Encyclopedia of Life, which is a website that we're building to host literally a page for every species on the planet. And we presently are at 1.34 million pages towards a target of 1.9. So ultimately, I think that the popularity of museums remains high. Funding is challenging, but most of the museums in the country are in local markets where the markets realize the value to the education of their youth and families. And it's very much my goal as the director of this museum to use the Smithsonian's Natural History Museum to improve the health of natural history museums and science centers across the country. And we're in contact with the Association of Science and Technology Centers to think about how we can bring science back into science centers and support this national endeavor.
Comment on that. I think this is a very interesting question, because at one time you could think of a formal track and an informal track, and they did their separate things. I believe that the informal track has shrunk because of the need to meet state standards and so forth. And as a result, there's a gap there for us to fill, and that the Smithsonian and other science centers are moving much more closely into the formal education sphere. And we can do that effectively through programs like digital badging, where we can give youngsters credentials for completing exercises and proving competency, if you will. And so we have about 100 different digital badges now that we offer in different programs that help teachers. We have 2,000 lesson plans available for free to teachers. Now, in addition to that sort of digital approach, we have a boots-on-the-ground approach in the Smithsonian Science Education Center. I mentioned we're working in 3 states, primarily with Title I students, where we work with principals, we work with teachers. We have 600 teachers a year to help them get comfortable in teaching science. We give them curriculum materials. We help the students learn, and we work with the community to support their schools and to transition through leadership changes with superintendents. So we believe we need to look at it from the point of view digital delivery, but boots on the ground and hardcore being in that space. We're just starting up a big program in Denver, matter of fact, in the same way.
The little time I have left, I wanted to go a little more into the issue of the provision in 2010 compete reauthorization that required OSTP to develop consistent policies for the management and disposal of federal scientific collections and develop an online clearinghouse for information on federal scientific collections. You talked a little bit about this already, but how are you working to achieve this, and what kind of collaborations do you have with federal agencies with large collections? You talked about general question with big data and where to store this, but can you provide further comments on how this process is coming along?
Well, I would want to mention that we co-chair with the USDA the Interagency Working Group on Scientific Collections, because I think across the government we are recognized as probably having the largest collection. So we're working with them on all of the standards, and Scott Miller is sitting behind me, and is our Deputy Undersecretary for Collections and Care, and he is the co-chair of that committee. I would also say that we work very closely every day with a number of the agencies that have large collections. USDA, Park Service, Department of Interior all have collections and staff that live at the National Museum of Natural History. So there's very close collaboration on a daily basis as well.
All right. See, my time is up there. I will yield back. Thank you.
Thank you very much. I now recognize Mr. Massey. 5 minutes.
Thank you, Mr. Chairman. I see some nice, look like 3D models up there that come from some of the artifacts that were scanned, I presume. One question that I have is, do you allow public use of all of your 3D models? Can people who have a 3D printer go and get these models? And what sort of efforts do you have to promote those 3D models, if so?
Well, we think 3D models have a great future, 3D imaging and 3D files, if you will, because it gives people access to our collections in ways they've never had before. It may not be exactly the real thing, but it sure looks like the real thing in many cases. So we have developed a three-dimensional imaging group, and we think it's the leading group in the world. We just had an international conference where hundreds of people came to the conference. We rolled out, in essence, our first collection of images that are fully 3D, ranging all the way from a ship, the gunboat Philadelphia in American history, down to a bee. To show the possibility, as well as, I guess the big one was we had a galaxy collapsing also that we imaged. But the idea was to illustrate the range of things we can do. That's accessible on our website. There's 20 objects. You can download the files and stuff. You can manipulate them when you're there. You can look at them in different colors. And what we learned from that exercise was many scholars are astounded because they can see things on objects they've never seen before. But these can be downloaded by a teacher in schools in your community. If they have access to a printer, some of these printers get to be very cheap now. They can print out the objects themselves. If they don't have access to a printer, there are internet sites now where you send these files to a company and they'll print it out for you. So we're making this available for free.
Are there any restrictions on the use of those data?
None
so they
whatsoever.
could show up in a movie and be used there as well?
Presumably, we have to be able.
Okay.
I will say that as I showed several members of the committee, we had this conference, and so they had demonstration technology there. One piece of which was they would take an image of anything within this cage, which happened to be in one instance me, and so I was imaged, and the next day they presented me with a 7-inch high model of myself, which my wife says is weird, but.
Yeah. I've got another question while we're talking about archiving in shapes. You know, it used to be popular to go out and shoot rare animals and stuff them. Is there any sort of contemporary version of that where we are cataloging DNA of existing species, for instance?
Yeah, we've one of the things we've realized is that every organism has an amazing amount of information in its genetic code, its genome, if you will. So every single organism is a unique example of life on the planet. And the best way to preserve that is to freeze it at very cold temperatures. And we've built in Suitland, Maryland, a repository with 5 million slots that is frozen. We use both nitrogen and deep cold freezers to preserve tissue samples of objects that we have the body of the object in the museum. So you have both the actual physical entity and the frozen tissue from which you can extract genetic information and genomic information. So we're realizing that the museum of the 21st century preserves both the body and the genetic components.
So, and along those lines, I think in other countries there's an effort to archive seeds, sort of to preserve at least the genetic diversity that we have among our agricultural crops and the opportunities to grow that. Those are always at risk because these things propagate on their own through pollen and through the wind. Do we have any sort of seed archive at the Smithsonian?
Only what you haven't done.
Yeah, so we actually do not have a seed bank. We do keep a number of animal gametes at the Smithsonian Conservation Biology Institute. So the fertile parts in rare and endangered species that we're breeding right now, we keep their gametes frozen. So that's basically effectively the seed of the animal, if you will. And we're breeding things like cheetahs and black-footed ferrets and maned wolves. So rare and endangered animals will preserve their reproductive output.
Great. So let's see. I just have one other question on climate change. What % of your budget is devoted to studying climate change or archiving that in sort of the contemporary debate right now over whether man is having an effect on that and to what degree?
I don't think we know the percentage as you describe it. The Smithsonian does a lot of research that relates to climate change. It's not directly focused on that. For example, we study bird migration patterns at the National Zoo. We know that bird migration patterns are changing because climate is changing. And so, but we study bird migration patterns and birds for other reasons than just that. But there are many areas where we are actually doing work that relates and illustrates climate change. We look at the acidification of ocean because we study reefs. And acidification of oceans affects reef, and it has something to do with the chemicals, the greenhouse gases that are in the atmosphere. So we do a lot of work that touches on climate change, but is not necessarily directed at that singular issue by itself.
Thank you very much. My time has expired.
I now recognize Ms. Kelly for questions.
Thank you, Mr. Chair, and thank you for being here. Under your leadership, Dr. Clough, the Smithsonian named Claudine Brown as its first Director of Education, now the Assistant Secretary for Education and Access. We've all heard the latest statistics from the Program for International Student Assessment, finding that American students are lagging further and further behind their international counterparts in math and science, scoring average to below average in these subjects. Unfortunately, these scores are even lower on average for minority students in communities with limited access to the kinds of advanced technology found in many higher achieving school districts and classrooms. Can you talk more about your efforts to broaden participation, and beyond counting the number of students your programs touch, how do you measure the impact on the students who go through these programs?
That's an excellent question. Dr. Brown has been essential to the work that we've been doing. We didn't have that position before, and many of our museums, as Kirk described, have wonderful education programs, but we wanted to coordinate them and use them in some capacity so more people can access the broadness and pick and choose what they need. What we've learned from teachers, for example, is they don't want our lesson plans per se. They would prefer us to provide them with a framework within which they can fill in and paint the palette, if you will, for their local communities, and so we've tried to work with them on that kind of concept. I think what we've tried to do is to take the multiple approach of there are places where boots on the ground are essential, and we can help teachers teach science better, because many teachers, as you know, not necessarily are credentialed in science. And so we try to help teachers get over that hump of being afraid of the subject that they've been asked to teach. They have no choice but to teach it. So we've worked at this now for 20 years, and we've gotten very good at it. Claudine's group also is working very closely with our affiliate museums to give them options for access to our materials. For example, in the sciences, we have about 50 of our affiliates, and the Burke just signed up, as a matter of fact, as one of our affiliates, that are science museums, our research centers. So recently, we got a grant from the Gates Foundation, and we created an option for our students to go to the Smithsonian Astrophysical Observatory and use their telescopes and talk to our scientists and to their educators and learn about the universe by actually talking. So active learning, we think, is a real key to what they do. We're also very grateful to the Gates Foundation for having given us a $30 million grant for our endowment called Reaching New Audiences. And so it's a competitive grant process, and all of our museums apply. And they have to come up with really good ideas to reach audiences we traditionally have not reached very well. And that's now in its third year. We've now given out $5 million. This is an endowment, so we use a spin worth of grants to reach new audiences, and we're really learning a lot about that. And educators from NSF and others now are joining us in these efforts. It's a collaborative effort, and it's exciting what we're seeing.
Wow, that's fantastic. Also, you mentioned in your testimony that the Smithsonian Science Education Center launched this new workforce development initiative. And just curious, why is that under the scope of the Smithsonian to concentrate on workforce issues, and how does that fit with your mission?
Well, what we are, you know, it's been an interesting thing because I came out of the university world, and I was used to a little more traditional age group in terms of the group you're targeting for education. The Smithsonian, we like to say, sort of starts with 2-year-olds and goes to 92-year-olds. So we have a lot of experience in educating people who are non-traditional learners, who are lifelong learners, who are curiosity-based learners, and adult learners. And we'd like to do families, the whole thing if we can, because that's also very helpful as well. But what we're learning from the Department of Labor, from the Department of Commerce, we work closely with the Patent and Trademark Office and the Department of Commerce. There's a big gap in terms of workforce training. We won't do all of that, but there are places where our digital badging program will be perfect for some of the material that we teach to late grade school students and others to help people get literacy and understand what they need for scientific literacy to do their work.
Thank you. I yield back.
Thank you very much. And now recognize Mr. Holmgren, 5 minutes.
Thank you, Mr. Chairman. Thank you all so much for being here. Thank you for your great work. I do think it's so important for us as a committee and as members of Congress to be having this conversation, and I believe so strongly in our museums. We had a very interesting hearing last week, I think, about STEM education, and specifically how do we inspire young people to get engaged in science and technology and engineering and mathematics. Very good hearing, but so much more work that we need to do. One of the things that really does bring us together as members of the House and Senate, Republicans and Democrats, is a need in our nation to be recommitted to STEM education. And I see museums as a key part of that. So thank you for your work. Also want to say thank you for your recognition of the young man, Jack Andreka, I think, Andreka, who invented the pancreatic cancer test strip. I got to meet him at Ideas Week in Chicago a year ago. So impressive, so energetic. But that's what it's all about, is getting young people excited and seeing that there's no barriers really at that age to have passion and pursue it, and that's what's so exciting to me. So thank you for your work. This is so important for us to discuss this so that we can prioritize with limited resources, prioritize funding, and also make sure that we're not wasting and doing duplicative type programs. I do want to focus a little bit on something that does concern me a little bit, or I've heard some concern from some of my local museums. When the administration decided to reorganize how STEM education was handled at the federal level, there were many in the stakeholder community who seemed taken by surprise with a proposal that they were not consulted about. Dr. Clough, the President's FY14 budget included an additional $25 million for the Smithsonian to become the lead agency to inform STEM education. Many in the informal education community that I've been in touch with in Illinois are concerned about this, especially since your organization cannot make external grants. Wondered what role you played in developing this new role for the Smithsonian, how you've responded to concerns from the STEM education community, and what I can take back to my local institutions.
Well, we did not have any role in formulating the plan for it. We heard about it rather late in the process. Like most, basically when we got our pass back, we learned that there was an effort to do this. Obviously, we had concerns ourselves when we first heard about it, because many of the agencies that were going to lose some of their capacity, we work with them. And in some cases, they fund us. And so, in air and space, we work with NASA in space education, and you go down to NIH and so forth. So we wanted to talk to our friends and try to understand what we could do. And if the plan were to go through, we wanted to make it one where we help them in any way. We felt, for example, if we were going to go through with this, that maybe 2 or 3 NASA educators would come to NSF and in essence be surrogates for NASA in our program, so they could help make sure we were doing the right thing on their behalf. I think what we learned out of this, now the whole effort eventually moved on, but we had a number of meetings that were very useful. It was an odd sort of process and it happened rather quickly. But it really brought all of us together in the STEM education field, and we started talking, and we found out places where we were doing things that others weren't doing and places where others were doing things we weren't doing. And we created some really remarkable new collaborations out of that. For example, I mentioned digital badging. It happened to be something that we've been very aggressive about with funding from the MacArthur Foundation. And so we were able to share what we're doing in digital badging, and now we have little groups coming together to talk about digital badging where we're sharing our insights about that. So in a way, it had this odd sort of positive benefit at the end of the day. Now, as far as the other museums are concerned, obviously we are the nation's museum, if you want, and we try to make a point about that. That's why we have 184 affiliate museums. So we have museums all over the country, many of which happen to be science museums. And we share everything we get. Our goal is, as soon as we do something, share it. As I mentioned with Colorful Cosmos was an unusual case where we did issue grant. We used the Gates Foundation money that I mentioned earlier, and we provided that to the regional museums that didn't have a lot of money. We give them a grant of $5,000 so they could advertise it thoroughly through their local schools and get as many young people as possible engaged in this great opportunity to work with our scientists at SAO. So we try to work very collaboratively with everyone wherever we go.
Let me follow up on it just real quick. My understanding is you can't make external grants specifically with your resources that you've been given. How is the institution able to partner with private sector organizations? You've talked about a little bit, I guess, with the Gates, but also just if you can further on that a little bit more of any other STEM education-related research or programs that you see moving forward, again, that could provide hope and encouragement, and maybe that's already been presented to a lot of these institutions, but I've heard some concern, I know, from some great institutions in the Chicago area.
Well, in our case, if you're taking a good example of that was the innovation grant at the Department of Education. It's very competitive to get in the game, and we were, because of our experience, chosen to go forward with that effort. But the Department of Education gave us $25 million. We had to raise $8 million privately. The idea is to engage the corporate community in the community so they get, if you will, skin in the game in their schools. And so we leverage federal dollars with private dollars to make this work. I mentioned we're in Denver, and it partly started when Kirk was still out at Denver. And we visited out there. We have 4 affiliates in the Denver area of our museum. We work very collaboratively with those 4 museums. The Science and Nature Museum is one of those. That effort's being entirely funded by the corporate community because they love what we're doing in our laser program, the one I mentioned, and they're more than willing to fund us to do this. And so in that case, it happens to be almost totally privately funded effort. But we're doing it in total collaboration with the local museums. In fact, the head of the Denver Museum is our champion in Denver to get that done.
My time is past expired. Thank you very much. I appreciate it, and I yield back, Chairman.
Thank you very much. Recognize Mr. Collins, 5 minutes.
Thank you, Mr. Chairman. I love your museums. I used to come down here in another life, and I would always come down the night before and pick one of your museums to go to. So I'm going to ask you a tough question. So I want to set the stage. I love museums. I love what you do. I'm a collector of a number of things. And so here's my question. When I was the county executive of Erie County, New York, largest upstate county, if you know our history, 1901 Pan Am Exposition, one of the wealthiest cities in the United States at the turn of the last century, now the 3rd poorest in the United States. But because of that history, we have one of the most magnificent science museums, one of the first in the country. We have a wonderful historical society. We've got one of the greatest rare books collections anywhere in the world. And Dr. Johnson, we're home to the Penn-Dixie Paleontology Site. I don't know if you visit us, but that's well known. So here's my issue. As county executive, we provided millions of dollars of funding to each of these institutions. And I remember a tour of the Science Museum, and they display about 2% of what they have. When I went into one room, honest to God, they had 1,000 spears, like from hundreds of years ago, and 10,000 arrowheads. And I'm pragmatic to a fault. I know I am. It's dollars and cents. But in this day, as Dr. Johnson said, funding for these museums is difficult, especially at the community level. What is your opinion of deaccessions? And if I've got 10,000 arrowheads and I got to store them, selling 8,000 of them, and you could raise big money. I'm not talking about selling the Hope Diamond, although I would wonder what that might bring, might dent our national debt. But could you just, for a local museum and local people, no one ever wants to give anything back, but let's face it, many of them have so much stuff they got to pay, and just kind of interested in your opinion, not at your level, but more at the local level.
Yeah, I think one of the important things to think about, collections are many things, and many of them formed in the late 1800s or early 1900s, and a lot of legacy collections out there. Museums that are well run do a fair amount of collections planning and collections improvement. And improvement includes both adding things to the collections, but also removing things from the collections that are no longer useful or needed. And it's a tricky business. And in some cases, things like rare and endangered species or Native American artifacts, it's very difficult to ethically dispose of them. So you might think this is no longer needed, but what's the right step to deaccession it and then remove it to a different place ethically? Often we find it takes more money to deaccession something than is available. So it's not a simple solution. There have been many museums who thought we can get out of the business of being museums and find that it actually costs more to get out of the business than it does to stay in the business. So it's challenged, but there has been a growing trend, and we're one of the leaders in the trend, of careful collections planning with the intent of collections improvement, because collections must be used to be housed in the collections arena. And we've done a lot of good work with that here. It's not just the condition of the collections, is what their intellectual value is. Is it something that we need to keep? Is there a reason for society to keep these objects in the public trust? So very hot topic in museology right now.
I'll just add to that. You're talking about arrowheads, which are pretty small. Well, we have some very large things in our collection, too. We have aircraft, many of them, and storing them is a huge challenge for us. And General Daly, who's the director of Air and Space, is very carefully and from time to time deaccessioning some of our aircraft to other aircraft museums around the country. So there are times when it is appropriate to deaccession, especially if we know that we can then make that artifact more available to more people.
I would just add one more thing to this. The opportune time to really make decisions about some of these things is when you're doing some major overhaul to a collection center. And we have military history uniforms at the Smithsonian and the American History Museum. And recently we were fortunate to really go after that collection center and update it and upgrade it. And it turned out we had many duplicates of those uniforms, and there was no reason for us to have those. And as you know, there are many military museums around the country. And so we deaccession by giving them to other museums that had a case for those objects.
Well, you know, and I appreciate that. It's just I can tell you when I mentioned that at a board meeting, there was a hush in the room that's even hard to describe when I thought of doing it, not to give it to another museum, but to sell it for money to help fund the operations. That didn't go over real well. But, you know, in this day and age, you've got to consider things. As you said, whether it's uniforms or other objects, there is a value there. And so forth. Well, again, my time's expired, but thank you for letting us enjoy your exhibits today. And again, I'm a big fan of yours, and thank you for all you do.
Thank you.
Well, thank you very much to all the witnesses. It's been fascinating testimony, and thanks for bringing the scientists for bringing all of your objects from the Smithsonian. We have a nice military museum, by the way, in Vincennes, Indiana, a small private guy that would appreciate a few planes if you're getting rid of any of them. You know? It's a guy actually who started a collection when he was in high school, and now he's probably late 60s, and over the years he has collected, and he of course travels the country meeting all kinds of people, and people give him things because they know him. It's fascinating. The record will remain open for 2 weeks for additional comments and written questions from the members. At this point, the witnesses are excused and the hearing is adjourned.
Thank you.